So thank you very much. Good afternoon, and thanks for this opportunity to present you the Copernicus Land Monitoring Service. My name is Marco Clerici. I work for the DG JRC of the European Commission, and we are an entrusted entity for the implementation of Copernicus, the global land component, together with EA, who is taking care mainly of the European component. So you already saw what is Copernicus in brief, just to highlight you the different components. So indeed, there is a space components, including different satellites for different type of measurements. And these raw data, together with data sets coming from contributing missions, so other mission than the Sentinel, and with the in situ data, they feed the six main Copernicus services. So you have seen already in the presentation some example of the satellites. I think the most used were Sentinel-1, who is a polar orbiting radar imager, and similarly to the Sentinel-6, still already launched actually, and the Sentinel-2 higher resolution imager, and the Sentinel-3. So when we go to the Copernicus data distribution, there was a recent initiative of the Commission to launch, that was done in 2023, the Copernicus data space ecosystem as a single platform for data access directly by downloading the products, but also for hosted computing on this cloud computing platform, and is replacing the previous hubs. There were different hubs, open and international hubs, but in the future, in the coming years, everything is going to be taken over by the CDSC. 6 services were already mentioned. Now, obviously, we are going to look at the land monitoring service, which has a number of different components. The first one is for the biogeophysical variables. Then the priority area monitoring, also called hotspots, land cover and land use mapping, which has both an European and a global component, and we are going to focus more on the global component. And then some other components maybe less relevant for your interest, the ground motion monitoring, satellite data, and the reference and validation data. Also in global land, we have in situ data that are used mainly for the validation and the calibration of the algorithm. So here you can see the link to reach this page where you can see the portfolio of products. So if we focus on the biophysical variables, you see some examples here: FAPAR, dry matter productivity, different index, some vegetation indexes like NDVI, but also burn areas and land surface temperature. Actually, this is the portfolio of products. You can appreciate that the products are generated at different resolutions. And for instance, for the vegetation ones, we had a sequence of different satellites, starting with vegetation, spot VGT, then ProbaV, and now OLCI on board Sentinel-3. And you can find the products mainly at 2 different resolutions for this vegetation category, 300 meters and 1 kilometer. Altogether, there are 21 type of products, more than 80 data collections. All the data, and this is really the Copernicus philosophy, are fairly available, quality assessed, and fully documented. And indeed, there is a long-term commitment of the Commission to continue until 2040 the provision of the Copernicus services. Here the 4 main categories for the biophysical, geobiophysical variable: vegetation, energy, water, cryosphere. And you see also a bit the level of maturity of the products. So the one in bold are operational, while the one here in light gray are still to be deployed, so not really fully operational. Some application fields, they can be used indeed in agriculture. We will see a number of examples of usage for crop monitoring, yield forecasting, and assessment of a biomass condition. But also, and then there is a linkage with the Copernicus emergency service for monitoring extreme events like drought, frost condition, heat waves, and also for the water category, a link with the hydrology application like water management, river discharge assessment, and also climate change for the climate flux forecast. So we see here some example of the vegetation category. The use of FAPAR for biomass estimation, which was done in Senegal by CSE, which is also part of the GMS in Africa, and the derivation of the start of a wet season from a soil water index done by GeoVille, and also other example, also FAO and a number of NGOs are basing their activity on the Copernicus land monitoring products. As JRC, we have been associated also to this initiative for enabling African institutions in exploiting the Earth observation data, and in particular Copernicus land monitoring service products like MESA, and now GMS in Africa. And you saw already a couple of presentations for GMS in Africa, which is linked to the marine and land European Copernicus services. So here are some other examples still for the category of vegetation and energy. Use of the products in Morocco by INRA, Botswana by BDMES, and in Kenya, and also some assessment by SASCAL, and also from the private sector, a number of companies are using Copernicus Global Land for their assessment of the environment. Here an example specifically for Botswana, and it's nice somehow because it does present the full cycle of the data chain value to move from the remote sensing data, in this case anomaly of precipitations and vegetation, to assess a possible drought condition that was then verified on the field and led to a report presented at the Minister at Parliament, and then the declaration of a drought condition. So the goal of projects like GMS in Africa is really to establish this chain for the information from the thematicians and the scientists to go to the decision-making level and then to the general public. Some other example of application, and go pretty fast through that because there are really a large number of slides in this presentation. So for agriculture, for crop monitoring, here are a number of publications that were built on this category of products, and also a new product which is under development, this GreenS product, that allow identifying somehow the age of the vegetation. So the one in the red here is very fresh, very new vegetation, and goes up to 4 decades from the first detection of vegetation. These areas are locust breeding areas, and it's important to identify the greenness of the vegetation, so there's some of the onset of the vegetation as soon as possible. Now we move to another category of products, the inland water. There are variable for the temperature of the lake water surface, but also the quality of the water, the detection of the water bodies and the water level. So also here we have a number of applications. Here a study done on the turbidity, both real time, so the most recent data, but also through a time series of 10 years, the identification of a of turbidity does change from April, May to September, October, for instance. That's again an example where we see also an application of the water variables for combined with hydrological models in order to detect and forecast also flooding events. Yeah, that's just zooming a bit to this lake, Turkana in Kenya. So water quality linked to the SDG number. The water quality product is available over more than 4,000 lakes. Resolution of the product is 300 meters and can be used in this case to monitor the turbidity after a dam. And then we move from the biophysical variables to the second big category of products, which is the global land cover product. This was initially generated since 2015 from power vegetation, so at 100-meter resolution on a yearly basis and at a global level. Now we moved to Sentinel-2. The product is still distributed at 100 meters, but computed at the full resolution of 10 meters. There are 23 classes and fractions. And here, through the new contracts, because as you probably know, Copernicus has different phases. We are in the second one. So we established new framework contracts, and there is a specific component in this new series of contracts for generating, in particular, tropical tree cover mapping to detect the forest changes in particular. Here is an example of utilization of a land cover map by FAO. In Sudan, in the Khartoum region, was possible to identify as classes of a classification the cropland rain-fed, here more dark, and in lighter pink, the cropland irrigated. So that's possible to to exploit these products to monitor also the water productivity. Other the application of the hotspot component. Now this is the third component, the hotspot, which is even at higher resolution than the global land classification. Hotspot is really focusing on some specific areas we identify in Africa mainly, but also in Southeast Asia, in order to generate very high resolution maps. So that's done also yearly, and is for the biodiversity and also for the agriculture. So here is an example of application for biodiversity. We are looking at this complex in DRC, and you see what is the pressure on the protected area for artificial coming from um, settlement, human settlement, so built up areas. And that's very important to monitor these protected areas, also to see how effective is the legislation, the local legislation, and the protection of the areas, and what's really the pressure and from which factors, so human settlement rather than agriculture and so on, deforestation, logging, and so on. So indeed, there are also some scientific publications based on these products, and here is the application more for agriculture. So still looking at the hotspot component, but more for the agriculture. So the starting point are time series of Sentinel-2 images with 5-day revisit period. They go through a machine learning algorithm for the classification. So you can appreciate here on the right what's the resolution of Prova B, 300 meter, the much better resolution of Sentinel-2. But in this component, with respect to the global land cover, we have also higher resolution, like coming from Digital Globe, to reach this type of assessment. This is a part of an effort JRC is doing since a long time, also independently from Copernicus, to the global agricultural monitoring support. Here we see an example of 3 different countries where the first campaign was completed for the 3 of them, the in-season mapping and also end-of-season mapping. and also the second one, second field campaign has to start. So here we can also appreciate the surface covered in Kenya, Uganda, and Tanzania. And the third application of the global mapping is about tropical forest monitoring. There we generate maps at different stages, different epoch, like 2018, 2020 in this case, mainly for the detection of deforestation or forest degradation. So here you see in red highlighted the regions where there was deforestation. Another application of the same principle over a different region, in this case in Mexico, but also in the Central African Republic. And then we move to an additional tool which is made available on top of what we've seen already, what we have seen so far. We presented already to the GMS and Africa community because we believe can be very important. And we often hear in our meetings with the institution of GMS and Africa about the difficulty of accessing and retrieving the Sentinel-2 collection. So this component of the service is for the user to generate independently global mosaic of Sentinel-2. The user can select the spectral bands he is interested in, define the output resolution of the products, define the period and obviously the region, and then do a request for having this composite. Can be very short time, like 10 days or 1 month, but also yearly. And the service is generating by default over the tropical forest yearly composites, not to be computed on the fly. And then for the data access, we have now a new website, and here is the URL to reach it, which includes all the Copernicus land monitoring service products. So the one that used to belong to the global land and that were published through this website, but also the more, say, European products generated by the European Environment Agency, and is going to be the single entry point for all users. So this legacy website, we call it now legacy because it's still operating, but is meant to be replaced in the long run by the single new website. So just for you to be informed also on the evolution on the user side for the data distribution. That's all from my side. Thanks for your attention and available to answer questions, if any. Over to you.